Okay, so we're going to talk a little bit about parabolas today, and we're going to talk about basically the definition that you need to kind of have some background. So a parabola, you guys are used to seeing, you have something that kind of follows that curve when you throw something in the air. It starts towards the ground, goes up and comes back down because of gravity. What we're going to do is we're going to define that a little bit more explicitly today, and more from a geometric perspective. So a parabola is a curve where at any point is at an equal distance from the focus, which is a fixed point, and the directrix. So this is a picture of a downward facing parabola. Here's your directrix, and then here is your focus. So what that is saying is this point right here, where my mouse is going to be equal distance from the focus to the directrix. And even if I moved to over here, see if I moved to over here, it would still be the equal distance from that focus to that directrix. Now, a parabola, like we talked about yesterday, comes from cutting those that double cone. So this is a picture of my plane that's going to come through, and it's going to slice my cone. And what I get is this side picture, and this would be a right-facing parabola. I can change my angle to kind of slice at a different angle, and he looks a little bit more rounded. I can make him so he's a little bit more straight. You can see he kind of bubbles out a little bit more. He's becoming more looking like a hyperbola. So there are different ways you can kind of think about a parabola. I think the best picture is we have that double cone, and then we have that slight angle of our plane coming through, and there's a nice picture of a downward facing parabola again. So here's the definition of a parabola, and this is something that's going to eventually go onto your reference sheet. So a parabola is the set of all points in a plane, let's add that really quick, in a plane, equal distance from a particular line, which we're going to call the directrix, and a particular point, which we call the focus in the plane. Focus is a fixed point of the parabola. So if I just start off, and I'm going to do a really simple, here's my nice parabola. Ooh. So on that nice parabola, you're going to have this thing called the focal axis as well. And the focal axis is an important axis. And he is basically, we're going to think of him like your axis of symmetry from way back in geometry. So we're going to make this guy, we'll make him red. So your focal axis is going to cut that parabola in half. And on that focal axis, you're going to have something called the vertex. And the vertex occurs, and this is a definition you're going to need to know, the vertex occurs where the parabola touches that focal axis. So there's my focal axis, he's in red, and my vertex is where my parabola intersects that focal axis. So, vertex. Now we do know we have another point, and this point is the focus. I'm going to make him green. So there's my focus. The focus is on your focal axis. That's where he gets his name. And he is going to be on the same, kind of you think of the same line as your vertex. The distance between the focus and the vertex is called the focal length. And that focal length we give the letter P. So in between the focus and the vertex, this distance right here is called P, and that's known as your focal length. Okay? Now what's interesting is I'm going to go down here, another P units. So that distance right here, and we're going to call that actually negative P. The distance from the focus to the vertex is called P, and then the distance from the vertex down here to this secondary line is also considered a negative P, but that line down there is actually your directrix. So we had a picture in there of our directrix from our definition of a parabola. So there is our directrix. He is P units away from the vertex. So we go back and we look. So here's our directrix here in this parabola. There's your focus. So from here to here would be your focal length. That little bit right there, that would be your P. And then from your vertex over to your directrix would be your negative P. It's just a very basic picture of that nice parabola. And what this is saying is if I put a point right here, And we're just going to make that some arbitrary point. From my yellow to my green focus, or my yellow to my directrix, those are equal distances all the way around my parabola. Even if I put another dot right here, so yellow dot to that green line, yellow dot to my green dot, my focus, equal distances. So there's your directrix, and we talked about our focus, we talked about our focal length. Our focal width is nothing too crazy. Your focal width is going to be a perpendicular chord, which a chord is a line with endpoints. It's going to pass through the focus. And I guess we'd say it's a perpendicular chord. He's perpendicular to your focal axis. So here's my focal axis, that dashed red line. My focal width is going to be kind of an imaginary chord. We usually don't see it, so I'm going to make him a dashed line again. We'll make him orange. He's going to pass through the focus, be perpendicular to our red line, so from here to here. And what you need to know about your focal width, besides what we already have written, your focal width is the absolute value of 4p. So he does have an equation to know as well. So that orange line right in here, that is your focal width. It's how wide your parabola is, and it's always going to be the absolute value of 4p, whatever your p happens to be. Now what's kind of different about parabolas that we're going to talk about today is we have 4 different kinds of parabolas. We have parabolas that open up, we have parabolas that open down, we have parabolas that open to the right, we have parabolas that open to the left. So I'm going to give just a quick synopsis of all of these parabolas, and we're going to fill them in tomorrow on our reference sheet. Now, the first thing we're going to talk about is every single one of these guys has a lovely axis of symmetry, and we're going to make that axis of symmetry a red dashed line. The axis of symmetry we're really going to refer to from here on out as the focal axis. So here is our focal axis on all of these guys. Remember, it's the one that splits it in half. There are all of our focal axes. The next thing, every single one of these is going to have a vertex. The vertex is where that parabola touches your focal axis. So I'm just going to put a V there. So there's all your vertices, I should say. The next thing, every single one of these is going to have a focus. The focus has to be on your focal axis. He always goes inside the parabola, so I'm going to make him green. Here's all of my foci. That's the plural focus. I'm going to put an F next to that. The next thing we're going to add is the directrix. The directrix is never inside the parabola. He's always going to be hanging out outside the parabola. And he's always going to be perpendicular to your focal axis. So we'll make all of those green. So your directrix be right there. Directrix is outside. And in this case, the directrix is actually going to be vertical. And he's going to be vertical again. So let's call that directrix. And one last thing we're going to add is the distance from F, your focus to your vertice, that's P. So the distance from in here would be P, in here would be P, and in here that distance is P. And I don't want you to forget that over here would be negative P, and here would be negative P, and here would be negative P, and in here would be negative P.